So we're picking up where we left off last time, which is we were talking about build management. So all the housekeeping tasks associated with compiling your source files, trying to put them in a location where the compiled source files don't mix in with your original source files, getting it to run, giving it the appropriate information for your program to run. So there's a bunch of tasks involved in that, and it's possible to have bugs in that stuff as well. And that is, you've got stuff's not going to the right directory, you're not finding the appropriate dependency files that you need. So there's a lot of stuff that goes into just those housekeeping tasks involved with compiling and running your program. And so that's where Ant comes in. Okay? So once you get used to building an Ant task, which we looked at some, we're going to look at some more today, then you pretty much set up your directories the same way every time, set up your Ant tasks the same way every time. Pretty much your class path information at the top, although it looks complicated, it's mostly going to look the same every time. So this process can minimize and hopefully eliminate some of the bugs associated with compiling and running your program. Now there was a question last time of how would I do things how would I compile and run without Ant? Okay, and so let's take a look at that first. So I've set that up here at the bottom to compile. The Java-C instruction runs our interpreter and converts our text file into a .class file, which the interpreter can then read, and when it comes time to run your program, the interpreter runs those class files. So it doesn't compile it all the way to an executable. It uses the interpreter, so there is a compile step, but it's not, it can't execute on its own. Okay, so it needs the Java program to actually run. And so we set up our path so it can find the required executables. I've got to know where my Java interpreter is located, so when I run it, I'm running the appropriate executable. I've got to know for my Ant step, I've got to know where the Ant executable is. So I've got to specify those pieces of information in the path up here. The class path also has to be done within Ant if we're using Ant, but here I list separately all the dependencies that my files are going to require. And in particular, you can see this first one, ./source. Well, if I'm doing a manual compile, my .class files are pretty much good, unless I do a bunch of extra steps to move them to their own folder, which Ant does for me. My class files are going to end up in the same file of my source files. So I can specify my dependency to be the source directory, because that's where some of the class files are going to end up that other files are eventually going to need. Okay? So that, as well as we discussed, there's some compiled files in this jar file, which is just compressed class files, really. But I've got to have pointers to both of those spots so that when the compiler needs an external source file and it doesn't know where to look for it, I've got to give it a series of places to look. And so one thing I have to manually specify that you need to look in the source directory where all your other stuff is. That has to be told that. And then also, if you can't find anything there, which most of it's stuff that you're going to need, at least for our programs now, that's where they're going to be. Otherwise, you might need to look in this jar file, this JDOM jar file. So that's what the class path down here does. So the executables use the path. When I'm compiling and running, my dependencies use the class path. So those are just listing of directories where you might find stuff that you need to do whatever it is I've asked you to do. So for the compile step, I then have to list the .java file that I want compiled in addition to the dependency locations. Okay? And then, so that's Java-C. And Java is what I use to run the interpreter, which then loads up my class files and does whatever instructions it finds in there. So it needs to be told where the main method is. And of course, it still needs the same dependency information. Okay? So in fact, after using Ant for a while, you get used to having this stuff automated. So for me, in particular, I needed to fiddle around with the Java-C statement for a while before I got it to work. I knew that I had to have a class path, and I was pretty sure that this was the right class path. But exactly how to locate the .java file, should I do what I did down here when running it, when I'm using the package information? Remember, I said CSC 2310 indicates a folder, okay? And we use the package statement to identify it. Well, down here, I use the package type dot notation, which does indicate subfolders. But when I'm running Java-C, I use folder, okay? So some of those details about how to run these manually without using Ant to do it for me, you kind of forget once you get dependent upon Ant, okay? However, that will work. We should be able to compile and run with those statements, okay? So it worked, but it does do one annoying thing. Unless I want to put a bunch of additional instructions in here to make the class files be in a build directory, they're all going to be compiled together. So now I've annoyingly got a mixture of source files and class files, okay? And when your project gets really big, that becomes really annoying. So that's why programmers have developed this tendency to have their compiled files go into a separate directory, so that when they come look at their source files, they don't have to worry about their directory being clogged up with a bunch of other stuff that's not source files. Okay? So we would have to manually put some instructions in our batch file that do that for us as well, if that's what we want. Well, Ant's set up to do that, so we should use Ant to do it. But that's all called build management. Okay? When I start using another program to help me with this process of compiling and running, that's build management. So let's now go back to Ant, and I think we had gotten as far as getting ready. Well, I may have covered Ant run. Let's do it again. Okay, so Ant build. Well, I'll get to talk about that again because run has a dependency. So one of the things you can specify in Ant is when one task depends on another one being completed. So in fact, we also had I forget what it was called, but we had another task that was responsible for deleting the old build directory and creating a new empty one. That's to make sure that all my files get compiled every time I compile. Okay? The main reason for that is when we're dealing with generics, if you want to see all of your warnings, you need to recompile everything. If you've got a partial compile of files that haven't changed, and you recompile again, only the ones that have changed are going to be compiled again, and you're going to miss out on some errors if your previously compiled, sorry, not errors, but warnings, if your previously compiled files had warnings in them. Okay, errors that it won't compile. Okay, so let's go back and look at Ant. So to remind you, I had this task called clean, which just deletes the old build directory and creates a new one. Then our task build depends on clean, so clean runs first. And then you can see I'm using a Java-C, which means I'm trying to compile. That makes sense for the build task. I tell it where the source files are. I tell it where I want to put the build file, so it does all of the moving the files over to the build folder for me. I tell it what I want to use as the class path, so I can define, if I've got a bunch of tasks that require different class paths, I can define a bunch of different class paths. Okay? I don't usually do that because the number of things that I need for a particular project in terms of class path directories is, it's a handful. It doesn't usually get extremely large to where I'd want to separate it out into separate defined class paths. But I could just give them different names. So what I'm saying with the class paths is when it comes time to compile, and you need the file you're compiling has a dependency, first look in the build directory. I may have already compiled it. It may have been another source file that got compiled already. Then check the JDOM class files, check the JUnit class files. If you still haven't found it, check the Hamcrest jar file. So again, those jar files are just compressed class files. Okay? And I could define several of these if I needed to, but I don't need to. So I'm just going to say use that class path, and then make sure that you show me all of the warnings associated with generics. That's what that compiler arg did. But the Java C is how I know that build's sole responsibility is to run the compile step, and it's not going to run anything on its own. Okay? And then finally, where we left off, run depends on build. I'm using the Java instruction now, and I'm telling it where the main method is. Okay, so the tasks are slightly different. This one needs to have a main method specified. I can have several class files with main methods in them, but I tell my Java task which one I want to actually be run, and that's the one it will run. Okay? In fact, we've done that several times. I've had a whole bunch of classes dealing with rational numbers and other stuff that all had their own main method. And I want to run a different one, I just come in here and change which one I want to run. Okay? And notice that it's using the dot notation, the package notation, and not the slashes for folders. Because as we saw over here, that's what the Java step needs. So Ant does the same thing. Okay? And then finally, if I'm wanting to run some test cases, some JUnit test cases, well then I definitely need this class path, or it's not going to find the associated JUnit class files that it needs. Okay? So I tell it where the main method is, and it's inside one of these jar files. So if my class path were incomplete and didn't locate those other possible locations for additional class files, we would not be able to find this one. Ant would try and fail to find the associated file that presumably contains the main method that I'm supposed to be running. Okay? But we did include it right there, same set of class paths. And then I also tell it as a command line argument, which we'll talk more about, probably not today. So all I'm doing is telling it here which of my files contains the test cases that I expect to be run when this main method gets executed. Okay? There is a little bit of overhead if I want to pass parameters all the way from the command line. I want to pass them, so if I do a build, and then I've got some parameters that I want passed all the way to my program, there's some work that we have to do to make sure that the batch file processes those things correctly, passes it to Ant correctly, and then Ant passes it correctly to our program through an arg line equals whatever. So we would have to do some forwarding of those command line parameters before they actually make it into our program. Okay? So I don't necessarily want to do that today. So that's what this is doing. It's saying, it's pretending there really was no command line argument, but I'm saying, oh yeah, there was a command line argument, and here it is. Okay? I didn't actually provide one, but I hard-coded it in here, so it's going to get passed to the main method, JUnit core main method, and my test cases will be run. Okay? In this case, it was the rational number test thing that we looked at last time. Okay. So let's make sure that all that happens correctly. So now I've got Ant run back in here. Let's save that. Notice I got all my warnings, which I wanted for generics, even though these I can't get rid of. I want to see them. And then the program ran, and it was still doing some priority queue stuff from a while ago. Okay, it sorted the items based on the keyed item that we passed it. Okay, so that worked. Now what if I wanted both test and run? I want two tasks to execute. Okay, I want test to run and run my test cases, and then if I pass the test cases, go ahead and run a program. Let's see, let's make sure I save that. It only runs the first one. Okay? That's really annoying. We can trick it into running both of them if we tack on an extra keyword here in our batch file call. So without this call, it's only going to run the first one it comes across, the first Ant task. Okay? But if I use call, it should, hopefully this, I haven't tested this, hopefully this works. If I use call, it should run both of them. Okay? It did a build twice, because remember, test depends on build, which depends on clean, and then run also depends on build, which depends on clean. So it went through that process twice. I probably didn't really need to do all that stuff twice, but nevertheless, that was the easiest thing to try. So in the event that you want multiple tasks to run, and you want them to be called from a batch file separately, then you can still do that. Okay? But the vast majority of the time, I just want one or the other. So I'll have one of them commented out and then swap back and forth as I need to. Okay. So, except for, so it should, it should hopefully feel a little bit more comfortable with these targets down here. We haven't talked about assertions, so don't worry about that. Some of these parameters we don't really concern ourselves with because they're never going to change. But hopefully you could at least, if I wanted to do another type of test, I can copy and paste my target, change the name of it, change the file down here to the new one that contains the tests I want to run, and then call Ant test 2. Okay? So that's the level that I would really kind of expect you to be able to operate at, not necessarily knowing what every single one of these parameters is. Okay? So for example, if you decided to move or add a new class path, you get a new jar file that you want to use in one of your programs. Well, using all the stuff that's already here, copy and paste and put stuff in what looks like the appropriate form, and you'll have it. Okay? So having a template to work from makes this build management much easier than having to do everything from scratch every time. Okay? And then as your project grows, you'll be adding on new tasks, which are indicated using the target tags. And for the most part, probably leaving the stuff at the top alone, which is the most confusing stuff. Okay, let's make sure I didn't break anything. Okay, so now I'm going to talk about configuration management. And that is, so we've been using Ant. Last time we talked about JUnit, and the next thing is Git, okay, which are referred to, there's a whole bunch of different software packages that do what Git does, or attempt to do essentially what Git does. They're called SCMs, Software Configuration Managers. Okay? And they've got a pretty important job. So you guys are using Git, and well, Bitbucket is simply a place to store your repository so multiple people can get to it. The real work in the SCM is done locally by the Git program. Okay, so that's primarily what we'll be focusing on today here. They've got an important job because it's frequently the case that you have, well, a couple of possible instances are you've got multiple people working on the same set of files. And of course, you want them to be updated to the project in a coherent manner. Okay? So that's the first thing you're trying to do. You want to allow collaboration, and every once in a while, that may mean that multiple people are working on the exact same file. Probably most of the time, that's not going to happen. Even if you have multiple people working on a project, they might, if you have several files or 20 files in your project, chances are pretty good that they're not all working on the same file. Okay? So in that case, it's sufficient to, there's not going to be any collisions with respect to changes made to the project. Everyone's going to be able to commit, we'll talk more about that in a second, without interfering with one another. But we want to be able to allow multiple users to use the thing, and we want to be able to have them work on the same file at the same time, potentially. The second thing is, every once in a while, we may need to revert to an old version of our program. Okay? the situation is like this. So remember, we're using Agile, going all the way back to the first day. So we're making frequent distributions. Okay? The whole idea behind Agile is that we have frequently working closely with our customer. We're giving them updates that they can go and test and figure out if exactly that is what they wanted or we need to change direction. Okay? So doing that on a weekly basis or even more frequent is in the long run going to save us a lot of time. Okay? So what can happen is we can have given them, we make one of our milestones. Okay? We reach something major. So we've got these frequent distributions, but eventually we're going to want to say, okay, here's version 1.0 or 0.9 or whatever the case may be. So that's a bigger distribution to our client with probably many features that they've requested and fine-tuned over time. We start working on some new stuff. Okay, brand new stuff. Again, we're going to make frequent distributions and they're going to have comments on them. But we change direction. Okay, we start focusing on a new set of features. They find a bug, and a couple weeks go by, they find a bug in one of the old ones. Okay, so customer finds a bug in an old release. Okay, they've already been commenting on the new stuff too. But eventually one of the employees comes across a bug in an old release, an old feature that we thought we were done with. Okay? Well, because we're using Software Configuration Manager, that's not a big problem. We can obtain that old release that we made to our customer as it was and fix the bug in it. Okay? So what software configuration managers do, if I were going to say their most important task, is they track the evolution of a project. Okay? So we weren't ready to give them those new features. So we don't really want to fix the bug in the new stuff. We want to address exactly what their issue was in the previous release, the previous big release. So we want to go back to that version and fix the bug. Now eventually, we're going to want to fix it in the new stuff as well, the newer version. Okay? So that's called a branch. We branch off. We've now got two versions of the project being worked on. Eventually, they'll have to be merged back together. So sooner or later, when we're using this evolution system, merging stuff together is going to become a major issue. Okay? But we need to be able to go historically through the evolution of our project because we never know when we're going to need to pull one of those old versions out. Okay? So, how do we do that? How are we going to track this evolution? Do we want to store the contents of our project every hour? Okay, so what exactly criteria are we going to do to say, now I've made enough progress since the last time that I stored a snapshot of my project that I would like to store another snapshot of the project. If we base it on actual time intervals, why do you think that might be a bad idea if I say every hour I want to store the evolution of the project? Yeah. So it's way too often, so it's going to be a big waste of space, and probably many times, we got this thing called sleep where we don't do anything on the project. I don't want to be wasting space storing projects that have little or no changes to them. Okay? So what SCMs do is they let, of course, the team members decide when to take a snapshot. Okay? And furthermore, the SCM should be clever enough that it doesn't store the contents of all the files, but since the last time we took a snapshot, it should be smart enough to realize, well, probably most of the files are going to be completely unchanged. So it's going to document the changes that have been made to the project since the last time a snapshot was taken, which of course you guys hopefully realize that's what happens when you commit. Okay? You've decided that you've made enough changes since the last time you committed that it's time. Okay? Maybe you've got a small feature, you're ready for another small release. Maybe that's time to commit your project. Okay? So whatever, it's up to the team members to decide when to commit. Okay? So that's how that evolution gets tracked. Of course, we also need to keep track of versions. So another thing, a slightly more trivial thing that SCM actually does is it assigns a unique version number to each commit. Okay? Now some SCMs will let you specify major versus minor commits. And if it's a minor commit, it's going to update, let's say, from 0.9 to 0.91, something like that. And if it's a major commit, lots of changes, we might change the whole number, okay, whatever system. But that's to distinguish in your evolution of your project what has happened since the last commit. Is it a smaller one, or does it represent a big leap forward as far as your project milestones? Okay, you can easily look at the version number and make that determination. Okay, make sure I covered everything to that point. And of course, in addition to commit, so there's something called checkout. Commit is also sometimes referred to as check-in. Okay? You're changing the contents of your repository. You're changing what Git has stored as the current evolution of the project. It's now got a new, later version, more recent evolution of the project. That's what happens with commit. Checkout allows, it's really an important mechanism that allows multiple people to work on the project at the same time. So when you check out, of course, what you're doing is you're obtaining locally copy of the project. Okay, we call this a workspace. And there is a one-to-many relationship. So your remote repository presumably is the official version of the project. That's where your commits actually happen. Okay? But you can have multiple people check out that project, and they're going to get a copy of it locally to their machine. Okay, the entire project, its current state of evolution. Presumably the most recent, although you can request an earlier version. Okay, there's nothing to stop that from happening. In fact, that's what makes the problem I was outlining with respect to old bugs being fixed possible. So at any point in there, usually you're checking out the most recent version, but it's possible that you're checking out an ancient one. Okay? And maybe you want to compare them. Maybe you want to check out in two different workspaces, an old version and a new version. You want to manually, with your own eyes, see what kind of changes are made to particular files. Okay? And so that's the power of the SCM, is it lets you see the entire evolution. Okay? You don't normally go back that often. You're always working with the newest version. But every once in a while, you really need to see an old one. Okay, so let's suppose we're working on the latest version, but we've got several team members, let's say 10. Everybody's checking out the project, they've got their own local workspace, and there's the one-to-many relationship. We've got a remote repository, which is the official location of our, the evolution of our project. But many people can have workspaces that have a local copy of it. Okay? So now, of course, what can happen when we do that is merge conflicts. So now that I've got this one-to-many relationship, there's possibly nothing to stop people from working on the same few files, and then when they try to commit, there's a problem. Okay? So let me sort of outline it for you. So suppose we got two people that happen to be working on the same file, A and B. Okay? A commits. That creates a new version. Okay, so my repository gets updated, noting the changes that A made since the last time a successful commit was requested. Okay, we don't copy all the files; we only track the changes to the files. Okay, so A commits, no problem. Now B commits, we have an issue, and we've got a couple of choices about what we can do. Okay, the first one is pessimistic. Hope I can spell that right. Pessimistic, and then of course the second choice is the opposite, optimistic. So in pessimistic conflicts, we are in fact not going to allow both A and B to check out the same set of files. We are going to disallow any file that A has checked out, B cannot check out. Okay? So that would greatly simplify your SCM, building the SCM itself, because that's a major problem that you otherwise would have to deal with. Okay, but we're optimistic in here. So we're going to say we're going to let people check out the same set of files. Hey, they may not conflict with each other. Okay, A and B don't necessarily need to make changes to the same files. We're both working on the project. Even if they both need the same set of files, they may make changes to different files. Okay? Then when A commits, B can commit, there's no conflict. The problem can occur, though, that if B has been working on, A made a change to a file that B has also made a change to. Okay? Then B is responsible for merging the conflicts. In other words, B has to decide whether to keep A's version or B's version. Okay? So it is entirely possible that B gets this merge conflict. We've got some software, which I'll show you in a second, that's going to help us deal with this merge conflict. And it can look at the files, it can look at the original file, A's changes, and B's changes. How does it get those three things? Because remember, we've got the evolution of the project. So it's easy for us to determine what the files looked like before A made any changes, and then after A made changes, and of course I've got my local changes. Okay, so the software has to be able to pick up on a few pieces of that evolution to show me those files. So now we go to the lab. Lab 4 is what I want. And KDiff3, you don't really need to read the text, but let me turn the light off anyway. Literally shows me what we were just discussing. All the way on the left, we have the base view. That is the file before A made any changes. The second one is local. That's my change. In fact, it's nice enough, this KDiff3 program is nice enough to show me all the lines that are in conflict. Okay, so it really makes this merge process pretty straightforward. And then on the right, we've got remote. which would be A's changes. Okay? And it tells us exactly which line, you can see highlighted in yellow, which line I need to deal with. The other lines are identical. I don't have to worry about those. Okay? But I need to decide whether I wanted to revert to the old one, which probably doesn't happen that often. My real decision is, do I want to keep mine or do I want to keep A's? Okay? And so the first button of note is, you probably can't see, but there's a bunch of annoying dots that we can get rid of by clicking that button there. Okay? And that will give us a slightly cleaner view that you probably can't see. Down here. Here. Okay, we still got base, local, and remote. Okay? Now, I need to select which one of those I want. I probably don't want the original, so I'm probably not going to click A here. Okay? It's between if I like my version or A's version of that particular line better. So I'm going to be selecting between B for this window or C for that window. Okay, so there's an A, B, C you can see circled in red there in my screen capture. Select one of them and line gets filled in. Okay? So it's as easy as that. You can just go through, if there's several conflicts, which probably there really would be, if there substantial changes have been made to the file, you just go through them one by one and select which one of those three views that you actually want for each and every line. Okay? Super convenient. And you can step-by-step instructions about how to set up Git to use this program, etc. They're all here. But that's the basic idea. Okay? So once you've handled all your merge conflicts, then you can go ahead and make your final commit. So in fact, suppose that I liked my version of stuff better. Here's what the evolution of my project will look like. I will not have lost anything. I will have actually not lost any information. Okay? Because I've got the original version. Of course, that's stored as its own version. Let's say 0.90. Okay? Then I'm going to have A's. When A made the commit, there were no merge conflicts because that was the first one to commit. Okay? And then when I came along and made my changes, so if later on I really decide, you know what, I think A was right, I was wrong, that's not a problem. We can do a branch and back up to check out A's version of the project and start evolving it as a separate project. In fact, we can keep both of these. See who ends up being right. Okay? So all the versions will still be there. So the process of resolving a merge conflict, it's really going to create 2 or more additional versions. Okay? Now I guess if I went back and selected all of A's choices, I actually don't know what would happen. Would it be smart enough to say, okay, B didn't really do anything, selected all of A's choices, so B actually made no changes? I guess if there were actually no changes, it would do a comparison, see there's no changes, and not create a new version. Okay? I imagine that's pretty rare. That probably really, in a merge conflict, some changes, maybe even not related to the file with the conflicts in it. Some changes have been made somewhere that are different between A and B and are going to justify 2 new versions. Okay? But I guess in principle, it could happen to where you select all of A's stuff, discard all of yours, and we don't need a new version. Okay? All right. All right. So one last thing to show. And that is a simple example of a branch, which I've mentioned a couple of times already. Okay? So from time to time, you need to go back to a previous version, as I was talking about with respect to finding a bug in an old release. You want to go back to that old release and fix the bug to address your clients, to fix the problem with the version that they're working with now. Okay? You gave them a major release. Yes, you're still giving them small releases on the new stuff, but their employees are working with that major release. Okay? The new stuff has bugs in it, and everybody knows that, including the customer. So they're working from an old major release. You need to fix the bug in that version and not fix it in the new one with all the incomplete stuff in it. Okay? So a major version presumably has not all the features, going all the way back to our first lecture about changing the scope. It doesn't have all the features, but the features it does have are pretty close to complete, and that's why it's a major version. Okay? Yes, we were continuing to work with that, adding on our new stuff here and here, but that's buggy and incomplete. Okay? So that's not where we want to fix the bug. We want to fix the bug in the version that they're working with, their employees are working with currently, that was supposed to be fairly complete, although many features had been left out. So that's how you might create multiple branches. Okay? However, at the end, at some point in the future, we want the bug fix that we made here to appear in my current main project line. Okay? So at some point, we're going to have to merge. Do you imagine that's going to be trivial or painful? That's probably going to be painful. Okay? I can think of one case where, one simplified version where it might not be so painful. If it turns out all we did down here was fix that bug, maybe it was one class file, maybe it was a handful of class files, and we weren't really messing with any of that old stuff in this stuff here. We were working on all of our new features. Okay? It may be that this merge step will not be that painful. There'll be some conflicts associated with those few files that might have had multiple changes in it, but it is entirely possible that if we didn't touch the old files with with our new stuff, that the merge will actually not even register any conflicts at all, or only a few. But that's really, tracking the evolution of a project is important for several reasons. Another one being, you get to a point where you made a change and you really regret it. So we're not really talking about branches here. Okay? So we're not going to be doing this. But I regret a decision that I made here and has totally made this code out here unworkable. And I would really like to go back to what I was doing before I made that decision and start over, because I don't really remember every single change that I made. Well, fortunately for me, my Git repository lets me back up and branch off, although I'm never going to merge back. I'm just going to keep going with this branch. And that has happened to me. I have saved myself several times with that ability to go back in time to a previous version of a program. Okay? It does happen that you regret decisions that had big consequences and you really wish that you could just undo them. And trying to remember everything that you did is virtually impossible. Okay? You try to back out some decisions and new stuff breaks, etc. So backing up, doing a branch but never followed back with a merge has actually saved me a couple of times. Okay, saved me a lot of time. And certainly I don't really want to have to start all the way over at the beginning. That would be bad too. Okay? But generally, more from a more realistic environment, you are going to branch and you will merge back at some point. Okay. Let's see. That covers the only other library that I might need to discuss that I gave you in your Java directory. So Ant, now you know that's our That's our build stuff. Okay? This bin directory, that contains the Java interpreter. So here's our program that helps us build. Here's our actual Java interpreter. JUnit, that's for testing. The only other thing that we have to worry about is what in the world is JDOM doing? Well, I frequently like to have information provided to my programs using XML. Okay, a lot of students use, well, there's a couple of ways. There's a couple of ways we can do this, XML being one. Another common one is JSON. And what these are self-explaining data. Or at least that's the intent. So XML has tags like title, whatever the title is. Okay, so it's got opening and closing tags that are supposed to document what the data stored between those tags actually is. JSON is similar, it's got a different syntax. Okay, I think actually people who use JSON a lot, have used both of them a lot, prefer JSON, but I've never used it. Okay, well what that JDOM folder is doing is it lets me parse these files and extract out the data that I need. Okay, so I have an XML parser that I use in Java, and I've got one that I use for my C++ programs. So every once in a while, we're going to need some of those files. Okay, I don't think we've used them, we've actually needed them yet, but at some point we will. And so that was the final piece of software that I gave you guys in that Java directory. So you were all set up from the beginning for everything that we would need through the entire semester. I do a similar thing when I teach C++. I have the GUI classes and all the other stuff right there in that main compiler directory. So I don't have to worry about it anymore. Once you get it up and running the first time, unless you guys go in there and start deleting directories or something, we're pretty much set for the semester. We have all the software that we need. Okay, so I think next time I've got one more chapter to cover in the textbook, and then we're going to start new Java stuff. And that will lead into a discussion about your first programming assignment. We're getting close. I think we're almost done with the introductory material. We can start the good stuff. All right, we're done.